All right, time for Unit 10, which is all about radical functions and graphing them and solving equations dealing with radical expressions. All right, so let's start off with some square root functions. Okay, so you've used square roots before. We've simplified them in the last unit. We used them to solve quadratic equations, and now we're going to graph some functions that have square roots in them. All right, so let's start with a little exploration. We got a couple functions here, and we want to graph them using a table of values and explore the domain and the range. Remember, the domain is which values? Oh, those are the possible x values, right? So you might try a number like -1 and put a -1. Well, that means we're going to find y is the square root of -1. Well, can you take the square root of -1? Well, with our experience, we know that no, we can't. There is no number that you can square to get -1. So this is undefined. Okay. All right, so we got an undefined. All right, anyways, so try some different numbers, 0, 1. You might try nice, neat numbers for, I don't know if 6 will do anything for you. Try it out, all right? Some of them might be decimals, okay? Check this guy out, x plus 2. You might try some like -2, 0, 2, 4, 6, 8. See where those take you and see what you can come up with, all right? So anyways, plug those in, graph them. You might get some decimal values. You can use your calculator to get your decimals and then plot them down below. Then see what you get. So pause the video, graph them, and come on back. Okay, hopefully you graphed them there and got something. I don't know if you use these numbers or not, but 0, the square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 6 gives about 2.4, and this is 3. So if we plot those points, we get something like this. Okay, and so we get these points right here. If we draw in our curve, so there we get something like that. And that should look familiar. It's kind of half of a parabola. The other half's down here. But we're not going to graph that half of a parabola turned on its side, we should say. So it is related to that, all right? So how about this guy? I don't know if you use these values or something else, but if you use these values, we get something like this. If we plug in -2, we get -2 plus 2, and that's going to be square root of 0, which is 0. If you plug in 0, you get the square root of 2, which is about 1.4. If you plug in 2, you get the square root of 2 plus 2, which is square root of 4. Square root of 4 is 2, so that's 2. If you plug 4 in here, you'll get the square root of 6, which you just found is about 2.4. If you plug 6 in there, you get the square root of 8, and the square root of 8 is about 2.8. If you plug 8 in there, you get 8. The square root of 10 and the square root of 10 gives about 3.2. All right, now you might have said, oh, well, 7 would be a smart one because that would be 7 plus 2, which is the square root of 9, and the square root of 9 is 3. Well, applying those points, we get something like this. So we get these points through here, and if we draw in the curve, it's not a line. We get that. Again, it looks like half of a parabola, the other half being down here, but that's not part of our graph. So that is our curve, okay? Now again, when we're graphing these kind of things by hand, we want to pick smart values, okay? So some smart ones would be like this, because when you put 7 in there, it becomes 9, and you get a perfect square root. We could plug -2, and that comes out to be a nice perfect number, perfect square. Plug 2 in there. Maybe another smart one might be if we plugged in -1. Okay, if you plug in -1, you're going to get the square root of 1, which is 1. Okay. So anyways, but we want to see the general form here, so we're looking for a pattern. Okay, so let's describe the domain and range here for each of these. Okay, for this first one, the domain, the possible x values, well, all the values that are positive, right? Can you put 0 in this? Yes, you can. So x is greater than 0 or equal to. Okay? So you can put 0 in there. What about the y values? Well, notice all of these y values are above the x-axis. There's one point that's right on the x-axis. So the range, we'll say, is all the y values that are greater than or equal to 0. Because there is one point that has a y value of 0. This guy right here. Okay? How about this one? Well, this guy has moved left. So it's moved left 2. So we have a domain of -2. So x is greater than or equal to -2. You can put -2 in here. But if you put anything less than -2, you got a problem. If you put -2.1 in here, you'll have the square root of -2.1 plus 2, and that's the square root of -0.1. That's a problem because it's a negative. Can't do that. Okay? So, all right. The range, as we can say again, are all the y values are above the x-axis, so the range is y is greater than or equal to 0. All right. So as we look at radical functions, we're going to see we have a domain restrictions because we don't want a negative in here. So we're going to look at that a bit. On the next page, here's kind of an interesting one. All right, we want to try to come up with a radical function, a square root function that will give us, be able to complete this table, okay? So I'm thinking of a mystery function. When I plug -4 in, I get 0. When I plug -1 in, I get the square root of 3. When I plug 0 in, we get 2. All right, so take a moment and see if you can think about what that function might be, and then see if you could fill in these numbers using that function. Okay, so I'll give you a hint. It's gonna be something like f of x. Okay, there's obviously going to be a square root. There's going to be an x in there somewhere, and there's going to be a plus or minus going on somewhere here. See what you can do. Did you find something? Well, when we plug -4 in, we get 0. Think about the last one. When we plugged in 2, we had 0. So I'm thinking maybe we can have a minus, actually a plus 4 there. Because when we plug -4 into here, -4 plus 4 is 0. So that would work there. Let's see if it works here. When you plug 0 in for x, 0 plus 4 is the square root of 4. Okay, so this would give us the square root of 0 plus 4, which is the square root of 4, which is 2. And that's good because that's what we got right here. And you can check for -1. If you plug in -1, you get the square root of 3. Okay, so there it is. We got it. So computing the rest of the values, we plug in -3, we got the square root of 1, which is 1. Plug in -2, we get the square root of 2, which we'll leave as the square root of 2. Plug in 1, we get the square root of 5, which we'll leave as the square root of 5. Simplify. Okay, simplest radical form that is. All right, try this guy. Here we have another pattern, and we got a little error in this pattern I just saw. Let's make this a 1. Okay, make this the number 1. Okay, so here's our pattern now. When we plug in -4, we get 1. When we plug in -1, we get 1 plus the square root of 3. When we plug in 0, we get 3. There's a connection between this and that. So try it out. We're going to have a function here. There's going to be a square root. There's going to be some stuff under the square root. There might be some stuff outside. Pause the video real quickly. See if you can come up with a function. Look for a connection between these and this one. Get the function, and then we'll see if we can fill it in. Did you find one? Well, if we plug in the same thing, because it's related here, we notice that these 0, the square root of 3, and 2 are all 1 less here. So looks like we could start with the same function. All we got to do is bump it up. So let's go outside the square root and add 1. And that would give it to us. That's why that 0 was a mistake there. So everything's going to be a little bit bigger. 1 plus the square root of 2. That's taking this thing over here, adding 1 to it. Take this thing over here, add 1. Take this thing, add 1. Take this thing, add 1. We get 1 plus the square root of 5. Okay, there you have it. So, all right, so, let's think about this. A couple quick things. What are some characteristics of the graph of a square root function? Well, whenever you graph a square root function, you're going to get something that looks like this. It's going to be a half parabola turned sideways, okay? All right. So something along that line, horizontal parabola, if you want to think of it that way, okay? So let's try this. And you can go to your graphing calculator or Desmos and try this out, all right? Graph these functions. Watch out, make sure that you have the 1 inside. Here the 1 is outside, the minus 1 is outside, okay? So go to Desmos there and graph it, see what you can come up with. Okay, graphing these here, if we explore, we've got this minus 1 on the inside. It's going to take it over here to the left, okay? And the shape is going to be like this. We're going to go, this is now like our 0, 0 from our regular square root of x. The square root of x is just going to look like what we saw up above. Starts at the origin, and it goes, for the square root of x, we're going to go from 0, 0, we're going to go over 1, up 1. Okay, or we should say it this way. Let me back that up. We're going to go up 1, because 1 squared is 1. We're going to go up 2, 2 squared is 4. Up 3, 3 squared is 9. So we're thinking like our parabola, but think in the opposite direction. So here, the minus 1 is going to move it left, so we're going to go up 1 and right 1, because 1 squared is 1. And then we're going to go up 2, and we're going to go right 1, 2, 3, 4, which will put us right there. Then from this little kind of a vertex, we're going to go up 3 and right 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. That puts us off the charts here. Okay, it's going to go like that. What's this minus 1 going to do? Well, it moves us down 1. So we're going to go down 1. And then we're going to do the same thing. Up 1, right 1, because 1 squared is 1. So again, we're thinking kind of, we're swapping the vertical and the horizontal from our parabola. So 2 squared is 4. Okay, so we've got 4 over there. 3 squared would be 9. That would put us somewhere out here. There's our parabola there. Okay? Our kind of sideways parabola. What's the 2 going to do? Well, that's going to make this a little taller. When you plug in 0, you still get 0. But when you plug in 1, the square root of 1 is 1, but it gets doubled. So it'll be twice as high. Okay? When you plug in 4, square root of 4 is 2. Okay? So we go over 4 and up 2, but instead of being here at 2, we're going to be up at twice as high. That's at 4. And when you plug in 9, you'd get the square root of 9, which is 3 times 2 is 6. So if you went all the way over to 9, we'd be up at 6. So it's going to be the same kind of little curvy thing, but it's going to be steeper, okay? And the negative guy is going to flip that upside down, okay? Go right 4, down 4. Okay, it almost looks a little straighter, but it's still a curve, okay? All right, that's how these work. Let's go to the next page. Quick vocabulary, a square root function is a function with a square root. That's a tough one. Or more specifically, a function with a variable with an x, let's say an x, and the square root, okay? If we have a radical function, well, it could be something that's not a square root, but is a cube root, okay? So same idea, a function with an x, or the independent variable in any kind of radical. Okay, so this could be like f of x equals 2 square root of x plus 3 minus 5. The x is in the square roots. Here it could be f of x equals 2 times the cube root of x minus 5. Plus 7, whatever. We got the x inside the radical here, but it's a cube root. Okay, so our transformations here now, okay, are going to be very similar. We'll look at these here. So square root function. Here's the idea once again. It's going to be this curve. It's really half of a parabola. And once we find this point that's not there's no vertex because there's not another half, but we can go up 1, right 1, up 2, right 4, up 3, right 9. Okay, and that's how we can find points on that regular square root curve, all right? And so shifts and transformations are very similar to what we've seen all year, okay? If we are subtracting inside the parentheses of the function, that's a horizontal translation. So subtracting goes right, adding goes left. Remember, it's opposite from what it seems, okay? If we add or subtract outside the square root function, it's going to move up or down. So if we add outside, it's going to move up, like 7 units up. If we subtract outside the radical, it's going to go down. Okay? When we put a negative inside, that's going to flip across the y-axis. That's a horizontal reflection. Put a negative on the outside, that flips across the x-axis. Vertical translation. Okay? If we multiply inside, that's going to be a horizontal shrink by the reciprocal 1/3. Remember, everything that goes on inside is opposite. Left and right is opposite. Shrinking and stretching is opposite from what we would expect. Okay, if you put 1/2 in here, well, it stretches horizontally. This is a horizontal stretch away or towards the y-axis. Okay, vertical is going to come from the stuff on the outside. That's multiplying this a value on the outside. 4 times the square root of x is going to make it go taller, stretch by 4. 1/2 is going to make it shrink by 1/5. 1/5, sorry, that's a 1/5. Can't read. All right, so anyways, those are very familiar, should be familiar, and so we can use those to graph. So let's try some of these out on the next page and see what we can do. So here you got some extra practice. You can try these out. The domain comes from the inside here. Okay, and algebraically, to find the domain, we want to just say, what makes this greater than or equal to 0? Okay, so the way to do this is to make an inequality like this and say negative x is greater than or equal to 0. Solve that inequality, and that gives you your domain. Okay, so one example here, find the domain of f of x equals the square root of negative 3x plus 5. Well, the domain would be this. We want negative 3x plus 5 to be greater than or equal to 0. This is how we find the domain. Okay, and we can subtract 5 from both sides. And we have negative 3x is greater than or equal to negative 5. Now you see what we want to do. We want to divide by negative 3. Divide by negative 3. And that's going to give us, those cancel. But what happens to an inequality when you divide by a negative? It flips the sign. Don't forget that. And negative 5 divided by negative 3 is 5/3. Okay? So x would be less than, that would be our domain. Our range, well, notice this is not moved up or down. There's nothing outside here. Okay, and it's not flipped or anything like that. So since it hasn't moved up or down, the range for this example would be y is greater than or equal to 0. And you can graph it to check that out to find out where your x's and y's are at. So set the inside greater than or equal to 0. That's what you want to do. Solve it. Flip the sign if you need to. And that tells you your domain. Okay. Range you can get from graphing and see what that comes up with. Okay. Or just notice if it's moved up or down. So, all right. We'll give those a try there and practice it up and you'll do well.